Module 2, How AI Learns. Overview. Understand how AI systems use training data to learn patterns. Grasp the critical principle of garbage in, garbage out. Poor data produces poor AI, regardless of algorithm sophistication. Learn to assess data quality and recognize why 60 to 80% of AI project time is data preparation. Module objectives. By completing this module, you will be able to explain how AI systems use training data to learn. Identify why data quality directly impacts AI performance. Recognize common data quality problems. Understand the costs and complexities of data preparation. Evaluate whether your organization has adequate data for an AI project. Lesson 2.1, Training Data, the Foundation. An AI system works by learning patterns from examples. Think of it as the difference between reading a book about driving and actually driving 10,000 miles. More experience equals better learning. How AI training works. Collection. Gather historical examples. To predict customer churn, collect data on 50,000 past customers, age, purchase history, support tickets, subscription length, whether they left. Feature engineering. Identify which attributes matter. Customer's favorite color probably doesn't predict churn, but days since last login likely does. 3-Training. Show the AI thousands of examples. It learns patterns like customers who go 30+ days without logging and have a 60% churn rate. Validation. Test on new data the AI hasn't seen. Does the pattern hold for these 10,000 new customers? Deployment. Use on real, new cases. Key point. The AI is learning correlations from data, not understanding in the human sense. It identifies, when X happens, Y tends to follow. Lesson 2.2, Garbage in, Garbage out problem. If training data is flawed, your AI will be flawed guaranteed. No algorithm sophistication can overcome poor data. Common data quality problems. Problem impact example. Incomplete data biased learning 40% of customer records missing income. Inaccurate data wrong patterns learned 2019 to 2020 COVID data for normal forecasting. Biased data perpetuates discrimination hiring AI trained on 80% male hires. Unrepresentative data poor generalization skin cancer AI trained only on light skin. Label errors learns wrong associations spam detector trained on mislabeled emails. Real example, a retail company tried to predict inventory demand using 2019 to 2020 data. Problem, COVID lockdowns made shopping patterns abnormal. The AI learned COVID patterns, not normal patterns. When business reopened, the AI overstocked. Massive losses. Lesson 2.3, The Cost of Data Preparation. Industry fact, 60 to 80% of AI project time is spent on data collection, cleaning, and preparation, not building the algorithm. Organizations dramatically underestimate data challenges. Data is siloed. Customer data lives in sales, support, and email systems. Combining them is technically and legally complex. Privacy constraints, GDPR, HIPAA, CCPA restrict how you use and share data. Data governance gaps. Who owns data? Who can access it? Unclear ownership slows projects. Scale issues. You might need 50,000 examples, but only have 2,000 historical records. Manual work. Cleaning, validating, and labeling data is tedious and time-consuming. Real case, a healthcare organization expected 2 months to prepare data for an AI readmission predictor. They discovered records spread across 3 hospital systems, merged companies. 10-year-old data in paper files, not digital. HIPAA restrictions on data sharing. Inconsistent data quality across systems. Result: 2 months became 12 months. The delay wasn't technical, it was data preparation. Lesson 2.4, Data Readiness Assessment. Before committing to an AI project, assess data readiness. Green flags ready for AI. Clean, well-documented data in centralized systems. Clear historical records of the outcome you're predicting. Data from relevant time periods and populations. Documented data validation and quality standards. Cross-functional team. Business plus IT plus data, aligned on project. Red flags, not ready for AI. Will gather data during development. Data siloed across systems, inconsistent, undocumented. Never measured the outcome you're trying to predict. Data is complex and poorly understood. Plan to replace experts instead of involving them. Case Study 2, the predictive maintenance AI that failed. What happened? A manufacturing company built an AI to predict equipment failures before they happened. Testing showed 85% accuracy. After deployment, the AI frequently predicted failures that never occurred, wasting maintenance resources. Root cause: equipment failures were logged inconsistently. Some failures recorded immediately, others days later. The company used 20 different phrases to describe failures. Training data was a mess. Additionally, historical data from 5 years ago was incomplete. The AI trained primarily on recent, well-documented failures, a biased subset that didn't represent true patterns. Impact: wasted maintenance costs. False alarms annoyed facility teams. Employees mistrusted the system. Project momentum died. Resolution: standardized failure logging across all equipment. Audited historical data for quality issues. Retrained AI on consistent, well-labeled data. Implemented ongoing data quality checks. Key lesson: the 85% accuracy was testing accuracy on clean data. Real-world accuracy was much lower because real-world data was messy. Data quality governance is ongoing, not one time. Module 2 Key Takeaways. AI learns from examples. More examples plus better examples equals better AI. Garbage in equals garbage out. Data quality directly determines AI quality. Data preparation is the bottleneck. Plan for 60 to 80% of project time on data work. Historical data must be representative. Biased data produces biased AI. Data governance is ongoing. Quality checks don't stop at deployment. Missing or mislabeled data is toxic. Even small error rates compound.